Okay, so in this video we're going to go over, we're going to review synthetic division. Alright, so up to now, in the previous video, we did lung division, right, where we had a problem set up in this manner. Okay, excuse me. Okay, and our goal here was to eliminate our leading term here. Where we had, okay, so 3x cubed, so we have an x, but no 3. So we need a 3 and then 2 more factors of x. So multiplying that out, we get 3x cubed plus 9x squared. Okay, we subtract. Leading term goes away. Negative 9x squared, we get negative 11x squared. Okay. Alright, and then again, same idea here. We match up these terms. So we have minus 11. We need one more factor of x. Okay, so 11x, we have negative 11x squared minus 33x. Alright, and then we'll subtract here, and that goes to 0, plus 33x plus 1x, 34x. Okay, and then again here, we'll match up. We already have a factor of x. The only thing here is a factor of 34, so we get 34x plus 102. Subtract, that goes to 0, and then here we get minus 106. And that is where we stop, right? Our remainder of 106. Alright, now, this can be, again, depending on our polynomial, can be rather tedious, right? There's a lot of steps here that we can do. There's actually a very nice and simple way to do something like this when certain conditions are met, right? The first condition is that we have our divisor is a linear binomial here. So linear, we have x and then just one other term, that being the constant. Right? And that the coefficient is 1 in our x. If it isn't, we'll go over an example of what we can do about that. But this must be, it must be a linear binomial. Okay, so that is met. And the idea here is, if you notice, all of these leading terms, right, 3, 3, the ones that we're going to eliminate, 11, right, 11, all right. And then the 33, so here, what happens here, 11, right, we're adding these terms, the 34 comes from the 33, and then from 11 multiplied by 3, then adding the x, right, etc., right? So it turns out we can actually write these in a very nice, complex way, and that's what our nice, straightforward kind of way. Right, the one thing we do is, since we are subtracting, so one thing I'm going to do here is, and this is what's called synthetic division. Once I have my factor here, I'm looking for factors that are of this form, x minus k. Okay, so if it's plus, all that means is that k is negative 3. Okay, so I'm going to write negative 3, and then I'm going to take all of my coefficients of my dividend. All right, 3, negative 2, 1, negative 4. All right. And then the first step is I'm just going to bring down that 3. All right. Okay. And again, notice same thing here, right? Matching up that first initial coefficient. And then from here we multiply. 3 times negative 3 is negative 9. And then we add. Multiply, add. All right, that's negative 11. Negative 11 times negative 3, negative 33. Excuse me, positive 33. And then we add, so that we get 34. 34 times negative 3, negative 102. And then we add, we get negative 106. And then we stop there. right? And that last one that we have here is always going to be my remainder. Okay, so we have our remainder here. Same as here, right? But now, if I start here, how do I get this, right? This is just a list of number, it looks like, right? So the idea here is that whenever you divide, right, by this linear binomial here, the new, or not new, I should say, our quotient is going to be 1 degree less. And these are the coefficients, right? So I started off with a cubic, so my quotient, I should say, is going to be an x squared. The next one is 11x, and then plus 34. Right? And my remainder is, and I'm going to write it like this. Looks something like that. Okay. Alright, so that's pretty straightforward, right? Again, as long as the condition is that our divisor looks something like this. Alright. Okay, let's try one more example here. So let's say I wanted to perform this operation. I want to take 9x cubed minus x plus 2 and divide that by 3x minus 1. Now I could do long division, but I saw that I noticed that the synthetic division is a much easier way to do this, more compact. Right? I can have it all in just a few lines there. But the only thing is that the divisor has to be something in this form. Well, that is not in this form. But actually, it is linear. The only thing is there's a term in front of the x. But I can actually fix that, right? I can factor out a 3. And I'll get something like this. Now that 3 does have to go somewhere. So the 3 in the numerator is the same as multiplying 1/3 in the denominator. So we get 3x cubed minus 1/3 x plus 2/3. All right, now that eliminates one of my issues. There's another thing that pops up here, is if we notice our synthetic division, the place where those numbers that I line up correspond to a coefficient of our x term, right? And which means we have to be careful which one we're representing. We have a cubic, there's no x squared term. So when I do my coefficient, right, the number here in the little box that I'll be multiplying every value with, it's going to be 1/3. And the first term is 3, but there's no x term. And I can't ignore that, right? So I need a placeholder for the x squared, and that placeholder being 0. And then so cubic squared linear term, and then a constant term, 2/3. Okay, so just be mindful of that, right? All of the powers need to be represented in our synthetic division, even if it's not in our dividend polynomial here. And then from here, right, just bring down the 3 first. Multiply. 3 times 1/3 is 1. Right, 1 plus 0 is 1. 1 times 1/3, 1/3. Add. Remember adding all the way here. 0, 0. We get 2/3. Okay. All right, so that means that I can write this as, so now putting this all together, my quotient here right? All these are equal, so I'll just start the original problem that I started with. Cubic, so my new polynomial is a quadratic, 3x squared plus x, no constant term, a remainder of 2/3 over x minus 1/3. since that is a factor that we are dividing with. And then here, let me clear this up. Multiply by 3 over 3. 3x minus 1. And there we go. That is our quotient, the remainder. And here our divisor. All right, thank you.